Hi guys, my name is Napatthorn and this video is for my physics project for our teacher Anchor. And today I will be presenting to you guys about simple harmonic motion, spring oscillations, and energy in simple harmonic motion. So first, let's actually understand what is simple harmonic motion. Basically, simple harmonic motion is when an object goes through a repeated motion when it vibrates or oscillates. An example of this motion can happen in a pendulum and in springs. And I will be talking about simple harmonic motion in spring oscillations in this video. Okay, for instance, let's say we bring up a spring system attached to an object of a certain mass that sits on a horizontal stationary surface. When there is no force exerted onto the system, a spring has its natural length at which the object sits at the equilibrium point, which I will highlight it as orange in this case. Now, realistically, there would be friction between the block and the surface, which would consequently bring the object to a stop. But let's assume that the surface is frictionless. Now, if we were to either push or pull the object and then release it, we can start to notice that the spring will now compress and stretch as the object oscillates back and forth. And for a quick fun fact, graphing the movement of the object to time would also show sinusoidal behavior. It demonstrates how the object covers the same displacement over a particular amount of time, which is known as period. Hence, this is a periodic motion. And of course, in different spring systems, the stiffness of the spring may vary, in which this factor is known as the spring constant, or K. Furthermore, we can use that to calculate the restoring force that the spring exerts by using Hooke's law, F equals to negative kx, in which the restoring force is always in the opposite direction to the displacement x, hence the negative sign. For example, when the displacement is in the positive direction as it is moving to the right, the restoring force will be exerted to the left, and this also applies the same when the direction is moving to the left. Furthermore, the units for the spring constant is newtons per meter, in which the distance x, or m, cancels out one another, leaving you the amount of force, F equals to n. Now please feel free to pause the video before I move into the next topic on energy in simple harmonic motion. Now finally, let's talk about the relationship between the two types of energy in simple harmonic motion, the potential energy and kinetic energy, in which when both combine, it will give us the total mechanical energy, where kinetic energy is equated as 1 over 2 mv squared, and elastic potential energy as 1 over 2 kx squared. And during the oscillation, it is also important to understand that there is always an interchange between the two energies. When the object reaches the maximum displacement or the amplitude on either sides, there is the greatest amount of elastic potential energy as the object is changing direction. And since displacement is directly proportional, potential energy is zero when there is no displacement at the equilibrium point. While on the other hand, kinetic energy is greatest when the object is moving towards the equilibrium position, in which the restoring force is being exerted. Okay, now let's solve a question together. So it says here that it takes a force of 91 newtons to compress the spring of a toy pop gun 0.175 meters to load a 0.160 kilograms ball. With what speed will the ball leave the gun if fired horizontally? So in this question, we're trying to find the speed. But in order to solve that, we have to first label out the given variables, which over here, they have given us the force, the distance, and the mass, which I will write it here first. Now, in order to find the speed, we know that we have to use the kinetic energy equation, which is 1/2 mv squared, which we're trying to find the v. But before we try to find v, we have to find the spring constant first by using Hooke's law, which is F equals to kx, in which in this case we can ignore the negative sign. Now we're just going to solve for k. To find the speed, we know that potential energy and kinetic energy is directly proportional to each other, which means they are equal. So we're just going to write here 1/2 kx squared equals to 1/2 mv squared. Now, what we're going to do is we have to use the variables that we know from here and over here and substitute them into the equation to find v. Now, that is pretty much it for this video, and thank you so much for watching.